So there are the graphs that Lewe produces. Lewe produces the first attempt to provide a means for technicians and engineers to make use of rightness analysis, combining membrane, shearing, and bending forces. His approach was to produce charts of curves and tables from which coefficients can be determined. Now, this is lifted from the Handbook for Eisenbettenbau, the engineer's manual. But it's a translation of theory. Here is theory. Here is the appendix of Lewe's dissertation. Coefficient tables. So, clearly demonstrating that these are simplifications of this. But what they are is more than simplifications. They are visualizations. You can have a visual representation of what's happening. The description through physics or engineering, you are given a visualization of what he's talking about. Okay, so Lewe, here we go. Very simple. I will not be dwelling long on it. Here is a load. It can be split. Here is a load. It can be split. It can be split infinitely. If you're examining for building structure collapse, you're looking for the point of failure, at the point at which stresses exceed the material strength and the thing breaks. So it's a way of analysing at the very infinite degree. And at the end of the document, he comes up with our favourite table of waves and loads. And so what he's saying is that when you split a load, when you can analyse the split, you find motion of waves. That was one that I did. I was picturing that the load finally fracturing, moving in this direction, because of the bending forces, the load finally fractures, but at the moment of fracture, this motion occurs as the load disintegrates. Now, what he's proven is two really important things. It's the positive moment. At this point, at position 5, on this page 7 of Lewe's dissertation, he shows the positive moment. He shows that this is the tension and bending. You can almost imagine this and do as an elastic membrane stretched between a sphere, across the equator of a sphere, inside it. It's a disc with a wave pattern on it. And you can see the wave has a droplet formed that's about to break. So the next motion should be, this should break. But because it's off center, because it's spinning, it creates a positive moment. This positive moment generates sufficient momentum within the system that this doesn't break, and it completes a whole rotation without the bubble bursting. Recognizing that we found the point at which the load does not fail. The structure will carry the forces that we put into it. He proves here we have the twisting forces. So these are the forces that he's analysed in splitting that infinite load to this level. And here he is demonstrating the twist. Here he is showing anti-clockwise curve, clockwise curve. And he's demonstrating that this is greater than this. The volume, the surface area under the curve is greater for the clockwise than for the anti-clockwise. Okay, and to go to the waves at the end. Okay, so that's it. So that's really Lewe. That's all he's done. Say all, but it's because I've skipped through all the matrix calculus. He just uses, the title is Matrix Calculus in Structural Analysis. But so the matrix calculus is the trick, it's the maths, it's the skill, it's a brilliant thing. but you don't need to know it. You just need to know what it's doing. And he's proving the wave patterns. Now, I'll take you to the last bit. So hopefully we can then start to join the visualizations now that you've had previously to what I'm talking. This is Lewe. 5 positions. Recognizing that in his figure, this one that we showed, it has 6 positions. And that's where the positive moment is shown. And I'm representing that here. So my justification for extending Lewe is that I'm just adding the 6th load case and the 6th position just for sheer balance, just for reasons of balance. I'm trying to balance that into a wave pattern. It doesn't work. And I get this. Okay, so it's exactly Lewe with just the extensions on the end. As I mentioned in the previous video, I've also added this complexity here into this area because this is the key point of this drawing, ab 5. Ab 5, yes. It's this clockwise motion here that's occurring. What's going on there in our positive moment? So this is my justification for this, making this move, because it then demonstrates what's actually happening with the load and why it doesn't fail. Okay. So I'm tracking this round and I'm going to turn the page as we go. So we can try to demonstrate some anti-clockwise motion here is what I was trying to do. So we've got position A. And here is the wave pattern from Lewe, load case A. I'm saying that this would be a stable condition. This would be the point where this wave, this trough, which is coloured in, shaded in, and the peak, which is not, is a spiral that's turning, and it's arrived at this point A, representing a freezing in time, and we'll look at that and we can see that's the shape that we're going to get. What's the next motion? From me, not from Lewe. When you balance this motion, this negative anti-clockwise vector is applying to this portion of the wave, and so we move to, it swirls to position B, the point moves across, and there is the peak has will be stretched and compressed here, that there'll be a wave will move in this direction on the crest to create this pattern here, balancing the load, the additional imbalanced load from that center trough moving to this position. It then spins back. So the center has now moved back, but we're carrying this wave motion from Lewe. At this point, D, the motion of the wave is captured by peak and a trough. At this point, a new center builds here in position D with the vectors. We spin to E. This wave is now grown from D. We've grown. This is growing again, back to trying to expand and to break at the center, trying to break at the center. The clockwise motion is now affecting the anti-clockwise motion and powering it, accelerating this. This motion is bringing to bear the wave celerity, the speed of the wave is being brought to bear on this motion by this negative vector, clockwise vector developing here. And at the last motion, it moves to this position. Stability again, represented here in a new system that's been created from the spiral. And then the next motion, it will return you back to the spiral. And it looks a complex move, doesn't it? But if you think about the center moving, I was trying to represent it here, where it's moving, it's going to go from here, from 1 to 2, it's going to go to 2 to 3, so it's going to go there. It's got anti-clockwise vector, so it's going to turn there, this is going to turn there, the rest of the waves will follow it, creating the new pattern. recognizing that these spirals, where they go off to a nothing, go off to infinity. Okay. So that's where I'm standing. Now, I can build an entire model of reality based on this pattern. And this is the new physics. It's replacing the sanctity of rest mass with the sanctity of inertia and eternal motion and the positive moment. That the simple move that we make within physics just needs to make this move. Go back, look at Lewe. Apply Lewe to E equals mc squared and to what you know. Apply it to all the problems that you have, of things you don't know, and see if it illuminates. Anyone's got any further steps on Lewe? Where to go? Take him. You can email me, message me, and with email I'll send you. I'll try and get it published somewhere. His dissertation. We just need to ask physics this. Please, have you checked your weird mysteries against Lewe? Everything else will fall into place. Trust me. So, I think I've done it. I understand it. And that's good enough for me. Thank you for listening. Love rules. Do the work. Cheers.